so we're all kind of know what a trapezoid is now. This is a picture of a trapezoid. This is the base. So we call base 1 and base 2. I could call this one base 1 and this one base 2. It doesn't matter. It's like base and height in a parallelogram. They're interchangeable, okay? Now the height is not interchangeable with the bases in a trapezoid though. So the height, also sometimes called the altitude, which makes sense. Altitude refers to how high something is, right? But the height of a trapezoid is the distance between the two bases. So remember, the two bases are parallel. In order for us to measure the distance between any two places, we need a line that's perpendicular between those two places, right? So if we want to know the distance between base 1 and base 2, we need to measure a line in between those that's perpendicular to them. Xavier, you gonna read what we're writing, bud? So the base and the height must be perpendicular. The bases and the height must be perpendicular. The formula for the area of a trapezoid, the area, remember how much space would this figure cover, is 1/2 times the height of that trapezoid times the sum of the bases. Now, y'all know by now, I'm going to use the height times base 1 plus base 2 divided by 2. They're the same thing. If you prefer 1/2 times the height times b1 plus b2, please do that. I'm okay with that. Sign in, Thomas. Okay, so just like yesterday, once we identify the base and the height of our figure, we'll plug it in the formula. We solve. It's a square unit of measure. From all areas, a square unit of measure. So the base, one of the bases, so base 1 and base 2, the sides that are parallel, this one and this one, right? 3 inches and 15 inches. The distance between those two bases is the height, and it's represented here as a dotted line. If they represent a dotted line in any figure, remember, it's not actually part of the trapezoid. It's not actually part of the triangle when we have the dotted lines. It's the distance, the length between these 2 points, where their endpoints are. So the height of this trapezoid is 8 inches. So if we plug into the formula for the area of a trapezoid, the height times the sum of the bases divided by 2 or multiplied by 1/2. So we can enter just like that on our calculator, but we do have to hit equals after the last parentheses. So it's going to be 8 times, you do have to use a time, less parentheses, 3 plus 15, close your parentheses, and then equals, and then divide by 2 and equals. What'd you get? What'd you get, Marielle? What'd you get there, Daryl? There. Why, every once in a while, I cannot remember what it is. 72. Yeah, now, is 72, if I put 72 in, do I get the right answer? No, what do I have to put in? Inches squared, right? I have to put in the unit of measure with the correct exponent on it. Just like yesterday. Okay, so do 8. Is it on degrees? The calculator just say DEG on it? Okay, so clear it out a couple times. Now do 8 times, left parentheses, 3 plus 15, right parentheses, equals, yep, then divided by 2. So in some of the calculators, you don't have to put in the multiplication. And I don't think you would have to put in the equal instead of like on the calculators we use here yet. So that's one of the reasons why we only let you use this one calculator. It's the only handheld calculator we let you use, because you can use this one on the EOC and we will provide it for you. All right, so find the area of this trapezoid. So we need the bases, base 1 and base 2, and we need the height. But I don't see a dotted line. Seems pretty apparent that these are the bases, right? They're the parallel sides. So it doesn't have to have a dotted line, but it does have to have a segment that is perpendicular to both those bases. So in this case, the height is, this segment that represents the height is also part of the trapezoid. So this is considered one of the legs of the trapezoid. If it's perpendicular to the bases, then that length is also the height. Does that make sense to everyone? All right, so now we're going to plug it in to our formula. It's the height times the sum of the bases divided by 2. Now, I could put 16 plus 12. Remember, that order doesn't matter. Everybody's going to practice putting it in on the calculator. 3 times left parentheses, 12 plus 16 right parentheses, equals divided by 2. What'd you get, Amaria? What'd you get, Tori? What'd you get, Miles? Yes. So 42, okay? Did I get the right answer? No, what do I need? Yeah, in this case it's actually meters squared, but yes, meters squared. All right. Doesn't matter which way the parallelogram, or the trapezoid rather, is turned either. The base and the height are still the parallel sides. The height is still the distance in between the two bases. They do give us the length of one of the legs. It's not necessarily the same length here, unless they told us this was an isosceles trapezoid, but it doesn't look like they're the same length, does it? So we're going to plug it into our formula. The height of the trapezoid times the sum of the bases, all divided by 2. Practicing putting it into you, okay, honey? Darren, you already got it? Okay. Thomas, you got it? What'd you get?
I got 77.
Is that what you got, Darren?
77.
What'd you get, Ibrielle? I think 77 is right. But we're going to include our unit of measure. It's also meters squared. So it doesn't matter which way it's turned. Sometimes there won't be a dotted line, but there will be an indication that they are perpendicular. All right, can you tell me what is the base? What are the bases of this trapezoid? Can you tell me what the bases of this trapezoid are, Devanshi? 6. Perfect. So 6 and 14, the height is always in between those two bases. Okay, so we're just going to plug it into our formula again. The height times the sum of the bases divided by 2. Sorry again. Got it? Did you zone out? Did you get it, Swan? What you got? Yep. Anybody get something different? Yeah. 6 and 14 is 20 times 5 is 100 divided by 2 is 50 square yards. sorry? 11 and 15. All right. And the height. Morgan, can you tell me the height? Say it again? Yes, exactly. So this is a perpendicular, it's a perpendicular segment in between these two bases. Happens to be one of the legs, but it's also the height. We're not going to scan and submit until after our assignment is turned in. So if you're getting your phone out, let's not do that yet. What'd you get, Miles? What'd you get for the area of example 5? 39. Xavier, did you do it yet? Yeah. What'd you get? Did anybody get something besides 39 meters squared? All right. Honestly, it's not going to get any harder than it is right there. Tomorrow we're going to work on topic goals in class, so you will have an assignment. 2 topic goals, I think. And then Thursday we'll do a combo assignment for 11-1 and 11-2. Monday we will take notes 11-3, and I think that's Rhombi and Kite. Oh, I do want to show you on your reference sheet. So remember where your reference sheet is on the home page. And some of these formulas that we have on here are on your reference sheet. So if you click there, you're going to open up the reference sheet, and you'll see the parallelogram formula is there, and the trapezoid formula is there. What's not there is the area formula for the rhombi and the kites that we're going to learn about on Monday. So you will have to remember those. Okay, so y'all can get started if you haven't already.